Hello student, previous video we saw 3 marker questions. Now in this video we'll see assertion and reason based questions. This question is asked in section A, 1 mark each. We studied that I told you in question paper pattern, that video you should see. In that 1 to 20 MCQs are there and 19 and 20 based on assertion and reason based questions. Now previous video we completed 3 mark questions. That previous video whatever questions we solved, that you have to study, and please share and subscribe that video. In this video, see here in this for these questions, whatever explanation about given the options, it will remain same. So you have to read properly and remember that whenever question is asked, that same description is coming for this A, B, C and D. This is the same description. So you have to remember also, means you have to read properly, and you can see how in these following questions A statement of assertions is following by the statement and of reason R. Means assertion A is given and reason R is given, and there is a option we have to choose. Now here options are there, both A and R are true and R is the correct explanation of A. Like this one option, both A and R the true but R is not correct explanation of A. A is a true but R is a false, and A is a false but R is true. This option will remain same when question is asked in question paper. This option will remain same. So we have to solve, we have to check that whatever statement is given, the statement of assertion and reason is given, then you will understand in question. Now here assertion that A, if SCF 336 and 54 equal to 6, means simple two numbers are given, and HCF of these two numbers is 6 and LCM of these two numbers is 3000. Okay, this is the A or assertion we can say. Then this is the reason. Here reason is given. Reason, sum of the exponents of prime factors in prime factorization of 196 is 4. Now here this we have to check. Here two numbers are given, SCF is given, LCM is given. So we have to find out. Here see, SCF into LCM equal to product of the two numbers, means we know this formula, we studied also. So SCF is 6 is given, then LCM, see, product of two numbers means 336 into 54, and here divided by 6, we have to find out the LCM. Then you are getting the LCM 3024, or here SCF we can find, means what, see here what is the given or what we solved. Here SCF and LCM is given. You have to check that is it correct or not. Two numbers are given, 6 is correct or not, LCM is 3000 is given. We have to give two things you can do that. See, by the prime factorization of 336 and 54, find the factors and find the SCF and LCM. Otherwise this way you can find out here SCF into LCM product. So first SCF writes means 6, means you have to find LCM, and then you know they have to find this 6 is transposing these sides coming upon here. So after solving reduced form, then LCM you are getting 3024. Then like this way you can find SCF. Now SCF equal to, you have to write, so 336 into 54 upon 3000. Then here answer is coming 60.48. So here assertion in means false, means both is not correct. Here 6 is given 3000. Here LCM we got 3024 and SCF we got 60.48, means both are wrong. Okay, so what is the here assertion is false. Okay, and here reason is sum of exponents of prime factors of prime factorization of 196 is 4. So what we have to do, 196 find the prime factorization. This prime factorization 2 square and 7 square, and sum of the exponent means 2 plus 2 4, means what, this reason is true. Whatever reason is given here regarding this one, sum of the exponent of prime factor in the factorization is 4. This is the correct, but this is not correct. So what we can see here, so reason is true and assertion is wrong, so answer is D. Then we know that the what is the description of D, that we have to see, and then answer is here D. Means we have to see first here assertion is wrong, reason is true, then in D option it is given A is false but R is true, so our option is D. Then second question here, see here A means assertion is SCF of two or more numbers is product of the smallest power of each common prime factors involved in the numbers. Then reason R, the SCF of 12 and 21 and 15 is 3. SCF of 12, 21 and 15 means 3 numbers are given, 12, 21 and 15. Their SCF is 3. See here, for example, means we have to now first we have to see the assertion. SCF of 2 or more number is SCF product of the smallest power of each common prime factors involved in the product. So here suppose 2, 4 and 8 numbers are given. Their factors are 2 raised to 1, 2 raised to 4. So SCF is what? Smallest power 2. Means here and then reason is what? Reason we have to SCF we have to find out this number. 12's factor is 2 into 2 into 3. 21 3 into 7, and see here index form we are writing 2 square into 3, 3 raised to 1 into 7 raised to 1. See here SCF, which is the common prime factor. See SCF is 3 means here 3 raised to 1, 3 raised to 1, 3 raised to, all are same, so one common we have to take, that is 3. Others are not common. So here this is the correct, means 3 is coming. SCF, this SCF of 12, 21 and 15 is 3, and here we got according to this product of the smallest power of each common. So for example, small number we have taken, then here smallest power is 2, that means that is the SCF, means your assertion is also true and reason is also true, so your answer means option A, first option. Then here statement means A assertion, if product of two numbers is 5718 and their SCF is 17, then their LCM is 314. Statement SCF is always factor of LCM. Now here see, we have to see first assertion. SCF is 17 and LCM is 340. Product of SCF and LCM 17 into 340. That product you have to multiply this. So if you are multiplying, then 5780 is coming. Okay. See here. 5780 is coming, but it is given that product of two number is 570. So it is very clear that product of two number is equal to the product of SCF and LCM. That means assertion is true. Now here SCF is always factor. Second is your reason is SCF is always factor of LCM, which is true, because when LCM we are finding means we are taking in many example. If you will see 2 marker questions and 3 marker questions, there we studied that some I have used also common LCM equal to common factors into uncommon. Common factor means SCF only. So product of uncommon factors and uncommon factors means it is a factor of that LCM means SCF. Uncommon factor into uncommon means both are factors of each other in LCM. So that common factor means SCF. So this statement is true. SCF is always factor of LCM. Here, but here see, but here reason is not correct explanation of assertion. Have you understood this? In this sentence here SCF is always, reason is correct, but this reason is not correct explanation of assertion. Have you understood? So answer is B. Now root x means this is the assertion is an irrational number where x is a prime number. Reason, square root of any prime number is a irrational number. So see here, always we know that square root of every prime number is irrational number. Square root, see here square root is given, that square root is called irrational number where x is a prime number. When square root of every prime number is irrational number, so both a and r are correct. Here square root of any prime number is irrational, so here option is A. Then fifth, this is the assertion, the SCF of two number is 18 and their product is 3072, then their LCM is 169. Reason, A and B are two positive integers, then SCF into LCM in equal to A into B. So we have to solve this. What is the given here? See, we know that any product of two numbers equal to SCF into LCM. We know that. So LCM is 18 into 169. Their product is coming, this multiplication is coming 3042, but here product is given 3072. This is not equal. So reason is true, because reason this is true. If A and B are two positive integers, then this formula we studied, this is true, but your assertion is not true. So here assertion is false, so option D will come. So we know that what is the option D that we studied. Now here assertion, the SCF of two number is 5 and their product is 150, then their LCM is 30. For any two positive integers A and B, SCF A and B plus LCM of A and B equal to A into B. So here see, first we have to solve, or we have to check this assertion, that is the SCF of two number is given. SCF is 5, LCM is 10, and A into B means 5 into 30, 150. So this is also 150 and this is also 1. So this is the correct, your A is correct, but R here plus is given. See, plus. So check that, don't get confused, multiplication and plus. Here plus is given, this means R is not correct, or it is a false. So option C will come. Then in 7, SCF of two number is 16 and their product is 3072, then their LCM is 162. If A and B are two positive integers, then SCF and LCM is equal to A into B. We know that this R is correct. Then solve this, SCF into LCM equal to A into B. 16 into 162, and this is given, actually this is given, no, see here product is given, so given. And if you are doing this multiplication of these two, LCM, SCF and LCM, 16 into 160, that multiplication is coming 2592, and their already product is, this is not equal, means A is false, but reason R is true. Then 8, here A assertion, for any two positive integers P and Q, SCF P and Q into LCM P and Q equal to P into Q. SCF of P and Q into LCM of P and Q equal to P into Q, means product of two given numbers. If the SCF of two number is 5 and their product is 150, then their LCM is 14. See here, here from the assertion, you know that assertion is correct, SCF into LCM equal to product. So assertion is correct. This formula we know that, we have to see the only reason. So here see, by the formula LCM into 5 equal to 150, LCM equal to 150 upon 5, that LCM is 30. LCM is 30 but given is 40, so LCM equal to 30, this is not equal to 40, means so reason is false. Reason is false and your assertion is correct. So find out this, your option. You have to, here this last question, find the answer, which option you will write. Okay, find answer means write here option. Okay, you have to do that.